So this lesson is about magnetic effect, and by the end of this lesson you should be able to draw the magnetic field around a conducting wire and also around a solenoid. And you'll also be able to use the right hand grip rule to determine which direction a field or a current is running through a wire. So before we begin, have a little go at these quick true or false starter questions. So if two north poles are put together, they're going to attract. That is a false statement. So two like poles together are actually going to repel. Next one is a true statement. The magnetic field strength is higher at the poles than it is around the side of a bar magnet. And the fact that a compass points north is evidence that the Earth has a magnetic field. That's also a true statement. Now, when a current runs through a wire, it will produce a magnetic field around that wire. So the current is running through, and you were to put a magnetic compass or a plotting compass around that wire, you would see that it creates a magnetic field around the wire. Now, the right hand grip rule is basically a way of being able to determine which direction the magnetic field is running. And so what you need to do is imagine grabbing the wire with your fingers and your thumb pointing up. So it's the right hand rule, all right? And what that basically means is the direction of your thumb, so your thumb will be pointing in the direction of the current, and your fingers will show which way around the magnetic field is. So if the current was reversed here, we would turn it the opposite way around. The current would be running down and the magnetic field would be running clockwise around the wire. So pause the video here and draw out these diagrams and see if you can add the arrows to show which way the magnetic field is at the top and which way the current is running at the bottom using that right hand rule. Okay, so there are the answers. So hopefully you realised if you look at the top, so we can see quite clearly, if we use the right hand rule, we can see the current running. If we change the direction, the magnetic field changes in the opposite direction, and again the same at the bottom. Now you often see these drawn when you draw these diagrams. You can see this is the more artistic way of drawing them, but actually in simple terms we can just draw them with an arrow representing the current, so that's the wire, and then we have this symbol, and that's the field coming out. So if you imagine that's your fingertips, that's the actual fingertips that you're looking at there. And if we look at the other side, we can imagine that has been an arrow that's going around the wire, and so that would be the feathers of the wire. And we can represent the diagrams like this. Now if we look at that with a coil of wire, so this is a coil of wire going round, what you'll notice is that here we have the magnetic field which is flowing around each of those wires is actually joining in the middle there, and that will increase the magnetic effect. And so if we look at this for a coil of wire, what we would find is the magnetic effect here, we can see that this is increasing, and here we've got quite a high magnetic field. Remember, the closer together the lines, the stronger the magnetic field. And if we have several coils of wire, we can see that what we get here, several coils of wire running round, this looks very similar to our magnetic field around a bar magnet, where the poles have the strongest magnetic field and around the sides is a weaker magnetic field. And this is basically what a solenoid is. It is just coils of wire. One of the things you may be asked to work out is which is the north and the south pole of a solenoid. And so we can look at the field pattern, and this will help us to decide. So to work out which end is which, you just look at the end and work out which way the current is running. And you need to decide whether it's running clockwise or anti-clockwise. And again, you use the right hand rule in order to do that. So if we've got a north, it will be running anti-clockwise, and if it's a south, it will be running clockwise. So have a look at this one here, and which way does this one run? So what pole would that be? and of course this one is a self pole. So hopefully you now will be able to draw a magnetic field around a conducting wire and also around a solenoid, and you'll also be able to use the right hand grip in order to show which way the magnetic field is running and which way the current is running.